Hello everyone and welcome back. My name is Mr. Cobalt and today I'm going to be going over how to use molarity as a conversion factor. And that's the most common way to use molarity. So again, just to remind you guys that molarity is, again, the capital M molarity is equal to moles of the solute, whatever's being dissolved, over liters of solution. So the solute and the solvent together, which is usually water. So this is your definition of molarity. And just remind you guys that whenever you have something over something or something per something, you can use that as a conversion factor because that they're relating two things together that you can use to convert one thing to the other. So I have three problems I'm going to go over, so let's get started. So in problem number one, how many liters of a 0.125 molar solution of NaOH contains this amount, 0.255 moles of NaOH? So remember, in the question, they tell you where to end and where to begin. So at the beginning of the question is the ending of your calculation. So how many liters? So we need to get to liters of our NaOH solution. So we need liters of NaOH solution. And where are we going to begin? Well, they tell us, if you keep reading, the rest of the question should tell us. So we need liters of NaOH solution contain 0.255 moles of NaOH. So we need to start with the moles of NaOH they give us. So we're starting with moles of NaOH. And then to go from moles to liters, you need to use conversion factors along the way. And so now we need to figure out, well, what are the conversion factors? Well, the only thing they gave us is molarity. So we're going to use molarity as a conversion factor. So we start with moles, because that's what they told us to start with. So we start with moles of NaOH, put that over 1, and now we need to go from moles to something else. Eventually we need liters. But it's a good thing they gave us molarity because molarity is a relationship between moles of solute, in this case NaOH, and liters of solution, NaOH. So we can use molarity to convert. So using the definition, so this means that 0.25 moles per 1 liter of the solution. So that means we have moles on top, so I'm going to put 0.125 moles of NaOH, and then I'm going to put 1 liter of the NaOH solution on top. And that is the definition of molarity. So all I've done is I've put liters of solution on top, moles on the bottom. So I flipped this. So now the moles of NaOH cancel out, and I'm left with liters, which is what they're asking me for. So at this point, I'm done with the conversions, and I'm going to calculate my answer. So I take moles. So the number of moles, I forgot to write down the number of moles. So I have 0.255 moles. So I'm going to take the 0.255 divided by 0.125 equals, and I get 2.04. So 2.04 liters of NaOH solution. So then I keep track of my Sig Figs. So I have 3 Sig Figs here, I have 3 there. I'm allowed to have 3 there, and that's what I have. So this would be my final answer, 2.04 liters of NaOH solution. So that's how you use it as a conversion factor. Let's try another problem, one that's a little bit more complicated. So here again, the question is going to tell you where to begin and where to end. And the beginning of the question is the ending of where you want to go. So how many grams of sucrose? That's where we want to go. Grams of sucrose. So we want to get to grams of sucrose. Where are we going to begin? It says how many grams of sucrose are in 1.5 liters of a 0.75 molar sucrose solution. So they give us two numbers here. What are we going to start with? 99 times out of 100, you're not going to start with a conversion factor. You're not going to start with something that is related to something else. So you're going to look for the thing that's not related to anything. So molarity is a relationship, moles to liters. So that is going to be used as a conversion factor. The only other thing is liters. Liters is not like linked or related to anything else. So that's where we're going to begin. So we want to go from liters to grams of sucrose. So liters of our solution, sucrose solution, to grams of sucrose. So we're going to start with liters. They give us 1.55, so we're going 1.55 liters of our sucrose. I'm going to solution, our sucrose solution over 1. And now we need to convert from liters. So now we can use our molarity. So molarity here is 0.758 moles per 1 liter. That's what that means. So again, if you write this out, it's molarity is equal to 0.758 moles per 1 liter of solution. So I'm going to use that as conversion. So I have liters on top, so 1 liter of solution. 1 liter of the sucrose solution on the bottom, and then moles goes on top. 0.758 moles of sucrose goes on top. So liters of the sucrose solution cancel out. I have moles of sucrose on the top. So the next thing I want to do is I need to get the grams. I have moles of sucrose. So what am I going to use to go from moles to grams? Molar mass. So I have the molar mass of sucrose written up here. So 342.30 grams per mole. So I'm going to do my next conversion factor. So 1 mole of sucrose on the bottom and 342.30 grams of sucrose on the top. So my moles of sucrose cancel out. Now I have grams of sucrose. So now all I need to do is calculate the answer. So I'm going to take 1.55 times 0.758 times 342.30. I have 1s on the bottom, so I'm not going to divide by that. Equals, and I get 402.168. So that's going to be 402.168 grams of sucrose. Okay, so now I need to check my Sig Figs. So I have 5 Sig Figs here, I have 3 here, and I have 3 here, so the least number is 3. So I need to cut it off at 402. That's a 1, so I just keep the 2 a 2, and I have 402 grams of sucrose. And that's how you do that. So that's another example of how to use molarity as a conversion factor. Okay, we have one more problem. In here, the problem is asking how many milliliters of 0.155 molar KCl solution contain 2.55 grams of KCl. So once again, I need to figure out where to begin and where to end. And so that's where the question is. And remember, the beginning of the question is where we're going to end in our calculation. So how many milliliters of our solution? So we need to get to milliliters of our KCl solution. That's where we gotta go. Okay, so that's where we end how are we going to get there? They gave us 0.155 molar KCl solution, and it contains, we want to know how much of that contains 2.55 grams. So again, we're not going to use molarity as the beginning because that is a relationship. We're going to use it as a conversion factor. So the only other thing that's by itself is 2.55 grams. So they want us to go from 2.55 grams. So we're going to go from grams of our KCl to milliliters of the KCl solution. So let's go ahead and do that. So we're going to set up our conversion again. So we have 2.55 grams of KCl, and we're going to put that over 1. Now, in order to use molarity, again, molarity is moles of solute to liters of solution, but we have grams of solute. So we need to convert grams to moles first if we're going to use this. So we got to use the molar mass. And I have the molar mass of KCl here, 74.55. So that's 74.55 grams of the KCl. And 1 mole of the KCl on top. So grams of KCl cancel out. Okay, now I have moles of KCl. So now I can use the molarity as a conversion factor. And again, this is the way this is interpreted is 1.55 moles per 1 liter. So I can use that as a conversion. So I have moles on the bottom, so I'm going to put 0.155 moles of the KCl on the bottom, and then on top I have 1 liter of KCl solution. Okay, moles cancel out, the moles of KCl cancel out. Now I have liters, volume. But they want milliliters, so I need to use my relationship of liters and milliliters. So I always put the 1 with the prefix, and then the prefix multiplier for milli is 10 to the negative 3. So there's my equality that I can use as a conversion factor. So I'm going to use that. So I'm going to multiply by my last conversion factor. So I have liters on top, so I'm going to put 10 to the negative 3 liters, and 1 milliliter on top, so liters of solution. This is going to be KCl solution, and this is KCl solution. And so now I have milliliters of KCl solution. So that's what they want, so I'm done. I'm done with the problem. So now all I have to do is calculate 2.55 times, this is 1, 1, and 1. So I'm going to divide, so I'm going to times, and then divide by 74.55 divided by 0.155, and then divided by 10 to the negative 3 equals, and I get 220.6. So 220.6789 milliliters of the KCl solution. So I got to figure out how many I'm allowed to keep, how many digits. So this is exact, 1 milliliter to liters, that's exact, I can ignore that. That's a measure, that's a measure, that's a measure. So I have 3 sig figs here, 4 here, 3 here. The least number is 3. So I gotta cut it off after the 0. So there's a 6 there, so the final answer is 221 milliliters of my KCl solution. I hope this is helpful in how to use molarity as a conversion factor. If you like this video, like it, share it, subscribe to the channel, make a comment in the comment section, let me know what you think, and hit the notification bell so you can get more videos. Thank you for joining me, and I'll see you next time.